Hi everyone, this is Babaiah, Assistant Professor of AC Department, MLR IIT Hyderabad. Today I am going to explain some rules of root locus technique, how to construct the root locus by using the some rules. So now I am going to explain some rules. Previous class also we learned some rules as well as basics of root locus and what is the importance of root locus. All this we learned from the previous session. But now I am going to continue the rules for the construction of root locus. For remaining rules, now we are going to see. Here, observe the next rule here. Coming to the breakaway point and break-in points. Here, calculate the breakaway and break-in points. First, we need to know the what is mean by breakaway and what is mean by break-in point. See, breakaway point is nothing but the any two adjacent poles. Any two adjacent poles are available in a root locus. In between, one breakaway point is definitely occur. Between the two poles, the root locus is existed. Then breakaway point is going to be occur. Okay. Next, break-in point. Break-in point is nothing but when the two adjacent zeros are available. Two adjacent zeros are available in real axis. There is a one root locus is existed between the two zeros. Then the break-in point going to be occurred. Understood? So here see the breakaway or break-in points either lie on real axis or exist as complex conjugate pairs. Real axis or as a complex conjugate or imaginary axis. If there is a root locus on real axis between two poles, between two poles, one root locus is existed. Then there is a one breakaway point. Okay. If there is a root locus on real axis between two zeros, then there exists a break in point. If there is a root locus on real axis between poles and zeros, then there may be or may not be breakaway or break-in point. Maybe it's going to be breakaway or break-in, or else there is a no breakaway break-in points. There is a no breakaway break-in points between the pole and zero. So here mainly breakaway point occurred when two adjacent poles are available. In the two adjacent poles means in between the two poles we have one root locus. There is a breakaway. Break-in point. Two adjacent zeros are available. In the two adjacent zeros we have one root locus. Their break-in point going to be existed. So let the characteristic equation be in the form, just we are going to write here b of s plus k a of s, that is equals to 0. For example, this is the characteristic equation. From that we are going to calculate the constant value k equals to minus b of s divided by a of s. So we are going to derivative this k with respect to s, then substitute equals to 0, then you are going to get the breakaway or break-in point. Always the gain k value, this k value is must be positive and real value. Okay, so then only breakaway or break-in point is valid. Breakaway or break-in point is occurred on root locus. See, the breakaway and break-in point is given by roots of characteristic equation, that is k equals to b of s divided by a of s. So for example here k is derivative, constant derivative with respect to s and equating to 0. Then the roots of dk by ds equals to 0. These roots are occur are actual breakaway or break-in point provided for this value of root. The gain case should be positive or real. So we need to follow dk by ds, that is equals to 0, 0, and here the k value equals to must be positive and real value. Then only this one is the breakaway or breakaway or valid breakaway or breaking point. Okay, if any not a real value, positive real value, is there any negative value is occur gain, so there is a no breakaway or breaking point. Simply remember that. Okay, first to calculate the breakaway breaking point, we are going to consider the characteristic equation from the given question, and that is the characteristic equation. Take the k value, constant value equals to some ratio values you should write. So derivative that k parameter gain with respect to s and equating to 0, you will get the sum. K value is positive value. That positive value is nothing but the breakaway or breaking point. Okay, so here breakaway breaking point, simply just how to represent here. For example, here this is the imaginary, right? Real, imaginary, breakaway and breaking point. See, one pole is here and one more pole is here present. In between these two, one root locus is existing. So always root locus start at the pole like this, start here poles, and here cross from here and or break from here. This point is nothing but the break away point. This is nothing but the break away point between two poles. Break away, adjacent two poles, break away or breaking point, imaginary and real. So 1 0 is available here, also 1 0 available, minus 1 minus 2, between these two one root locus is available. So always root locus start at the pole. So here somewhere start, it is somewhere start, so end it here, or somewhere start end here, start somewhere here. So infinity or some pole at start, end at the 0. This point is nothing but break in point, break in point. Understood how to represent breakaway and break in point? So here always breakaway break in points are in the k value is must be positive, real positive number. Okay, next coming to the next rule here. See, angle of departure and angle of arrival. So angle of departure and angle of arrival, this one also very important. Angle of departure is nothing but any complex pole is available. So complex poles are available in given question, then you are going to calculate the angle of departure definitely. Angle of arrival calculation for the any complex zeros are there. Angle of arrival calculation. So here see, angle of departure from a complex pole A. Here for example, this is the complex pole A. From a pole to remaining poles. Here this circle is 0, circle is 0. Here one pole, here also one pole. This angle and this angle, theta 1, theta 5. So here A to A3. Sorry, A, theta 3. Okay, this is the angles from complex pole to remaining pole. So see formula, 180 degrees minus sum of angles of vectors to the complex pole A to other poles. Angles here, complex pole to other poles angles, you should just sum here, that is 180 degrees minus that value. Next place sum of angles of vectors to the complex pole A from zeros, complex pole A to zeros. This one more 0 is there, here 0 is there, two angles, so that is the zeros. So you should sum that value. Always or all the angles can be calculated with using the protractor also. Protractor, you can use protractor and calculate the angle. Simply take the protractor here. What is the angle here? Here keep the, what is the angle? 90 degrees. Here keep the protractor and calculate the value like that. Or otherwise you don't have any protractor, in that condition we are going to use the formula. So formula, that value is 180 degrees minus tan inverse of a by b, or else tan inverse of angle calculation. What in previous session, tan inverse of imaginary part divided by real part. So imaginary by real. So here tan inverse of a by b, theta 1, here theta 1 is there, this term total value is what, 180 degrees, but we required only this part, so one part is there. So 180 degrees minus tan inverse of, complete this value is what, from here to here b is real and a is imaginary. So a by b from here to here total. Theta 1 calculation, 180 degrees minus tan inverse of b divided by total this value divided by a, imaginary part by real. Next to theta 2 calculation. So this is c from here to here. So c is there. So tan inverse of c divided by a, 180 degrees minus, because of this total 180 degrees, but we require this one. Next see here, this one is 90 degrees theta 3. So here see theta 4. So directly take the protractor, or else here consider this one. This one, tan inverse of d is real, a is imaginary. So a by d, a by d. Theta 5 from here to here e, and here a by e, tan inverse of imaginary part by real part. Like that we are going to calculate the angles, or else you can use the protractor directly just to measure the angle values. Okay, the calculation of angle of departure is like this. Departure, all the values, angle values, just to substitute here, you will get the angle of departure. Next coming to the angle of arrival. Angle of arrival, angle of arrival means here what, angle of departure is complex poles is available, complex zeros are there. Angle of arrival at complex zeros, are available, that 180 degrees minus sum of angles of vectors to the complex zeros a from all other zeros. Sum of angles of vectors to the complex zero a from other poles. Here poles, zeros first, because of angle of arrival for the zeros only, complex zeros. So complex zeros, so that's why here complex poles, complex poles for angle of departure, So here complex zeros, angle of arrival, 180 degrees minus sum of angle vectors complex zero a from all other. For example, this is a complex zero a. Next, sum of angles of vectors to the complex zero a from all the poles. See, same thing, observe here, theta 1 pole, and here theta 1 is 0, and here theta 3 also 0. This one pole and pole, and here 0. This one complex 0. So complex 0 available, so that's why we are going to calculate the angle of arrival. So from complex pole a to remaining pole, complex a 0 to remaining zeros, from here to here theta 3. So for this theta 3 plus, and here theta 1, these two zeros, so this one. Next here complex 0 to remaining poles, theta 2 theta 4, theta 5, theta 5. Okay, this is same thing we are going to use here, protractor, or else use the formula theta 1 180 degrees minus tan inverse of imaginary part by real. Same 180 degrees theta 1 minus total 180, write this from here to here. So that's why we required only this part. So 180 minus this part tan inverse of imaginary part by imaginary is a, real value is up to here, what C is there, sorry, up to here C is there, this one theta 2. Okay, theta 2 180 degrees minus tan inverse of A by C. But here B, this term theta 2 B by A, sorry, A is A by B. This is the theta 2, this is the theta 1. Okay, this is theta 1, this is theta 2. Just modify that. Theta 1 equals to 180 degrees minus tan inverse of A by C. Because of A, here complete value up to here is C, right? So A by C, this is theta 1. So theta 2 is B by A, or A by B. A is imaginary, so that's why. So theta 3 is 90 degrees, theta 4 equals to tan inverse of imaginary is A, D is real, A and E, like that. Okay, same thing we need to follow here. Calculation of angle of arrival, angle of departure and angle of arrival. Complex poles occur, angle of departure we need to calculate. Complex zeros are there, angle of arrival we need to calculate. Next to point of intersection of root locus, just to find the one point of intersection of root locus with imaginary axis. So here seems this is imaginary axis and real axis. So any root locus is just for example from here to one pole is there, here one pole is there, between one root locus is there. So it is like this, starting at pole and end at the 0. Here like this one going like this. For example, one point touch it, this root locus touch it point on the imaginary axis, here also touch on the imaginary axis. So we need to find these points also, that is the one more rule. So here find an intersection of root locus with imaginary axis. So for that we are going to calculate, we are going to consider the characteristic equation. Same here breakaway break-in points, like characteristic equation considered. After that arrange the array matrix, use the array matrix, that one method, or otherwise one more method, just to use the S equals to j omega, substitute in that characteristic equation, solve that, you will get some k values are there. So that observe the value, that point is on the imaginary part occur or not, just value, just observe by using this condition also, S equals to j omega, or else Routh-Hurwitz array matrix. It is very easy. So it is take the more calculation or more take time for S equals to j omega, or use trial and error approach. No need. First these two are very important, Routh-Hurwitz array and S equals to j omega substitute. The point where the root loci intersects the imaginary axis can be found the following three methods. This is the very important, and this one also very, these two are easy. So these two, you can use these two methods to solve the find the intersection point on imaginary axis. Easy methods. RH criterion or Routh-Hurwitz array matrix is easy. S equals to j omega substitute on the characteristic equation also, it will take more time. So you should consider this one or use this one, you will get the answer within the short time. Okay, so let S equals to j omega in the characteristic equation and separate the real part and imaginary part. Two equations are obtained from that, one by equating to real part to 0 and other equating to imaginary part to 0. Solve the two equations for omega and k values. Calculate the omega value, k value. The values of omega gives the points where the root locus crosses the imaginary axis. Omega value gives the points where the root locus going to be touch on the imaginary axis. The value of k gives the value of gain k at their crossing point. At crossing point, k value. Gain is, what is the gain? How much gain is occurred? So that gain, k value gives the gain of the crossing points. Also, this value k is limiting value of k for stability of the system. For limited stable or marginally stable, like that. For limited stable, the given system is stable system based on the limited value of k. That is, k is gives the some range. For example, 0 to 20. So between 0 to 20, or 0 less than or equals to 20 less than or equals to 30, like that. Any values are 0 less than or equals to some value, that is consider. Here any values you should consider. By solving the problem you can understand easily. So okay, so k value is range. It is range, some range values or limited range. In that particular range, the system is going to be stable system or limitedly stable or conditionally stable. Okay, so these are the rules to construct the root locus on a real axis. So these are the very important rules to draw the root locus. This is a graphical representation. We need to use the normal graph sheet and draw the root locus on that graph sheet. So from that, and also locate the roots on left side or right side. So easy to identify or follow. So higher order polynomial equation or higher order systems, the root locus technique is very useful to locate the poles on the real axis on the S-plane. Okay, these are the rules. See once again, see all these one by one. So some rules previous class. So all the remaining rules here. See, breakaway break-in point. What is breakaway point? Breakaway point occurred when two adjacent poles are there. It is breakaway point is occurred. In adjacent pole, one root locus is existed, then definitely breakaway point is occurred. Break-in point, two adjacent zeros are occurred and root locus in two adjacent zeros are there. In between the two zeros, one root locus is existed, then the break-in point is occurred. So how to calculate that breakaway break-in point? Simple. Just we are going to consider the characteristic equation from the question. Gain k value or parameter k equals to some, in terms you should write. After that, derivative that k with respect to s and equating to 0, you will get the some values, k values. That k value must be positive. Then the positive value, that is nothing but the breakaway or break-in point. Angle of departure, angle of arrival. When any complex poles are available, then we need to calculate the angle of departure. Angle of departure formula, this one very important. And also angle of arrival. When the complex zeros are available, then we need to calculate the angle of arrival. So this is also very important formula. You can remember all this. Next, how to calculate or find the intersection point on imaginary axis. Root locus intersection point. Just to use the Routh-Hurwitz array matrix or S equals to J omega, substitute in characteristic equation. So that is we follow. Or consider the characteristic equation, arrange the array matrix and observe the first column elements. Is there any sign changes are there? There is no sign changes, then the system is stable. Or between any limited k value is available, that k value, for example, we need to substitute some value between k value with some range. So limitedly, so system is going to be limitedly stable system, we say that. All these are the rules to construct the root locus. I hope you understand all these rules. Thank you all.